What's up, boy?
Hey, Leo.
Alright, so we're recording this for Leo today. Alright, you guys already have all of these. Didn't we talk about all of these?
Yes.
We talked about how we knew what most all of them were, except for a few. Now, these ones dotted. These are ones that we're going to learn more about this week. You guys already know that 3 angles of a triangle equal 180. So that's really nothing new, but we're going to prove it this week. You guys already know, well, you may or may not know that exterior angle is equal to the sum of the 2 remote interior angles. If you don't, we'll talk about that this week. Some of you may. And we're going to look at these also. So these are the ones we're going to do this week. Now, let's go back over some of these. Reflexive property we've used several times in proofs already, haven't we? Now, transitive property. This says if A equals B and B equals C, then A equals C. We're going to do something today where this could be applicable. All these addition, subtraction, postulates, that's just if we add equal amounts or subtract equal amounts, then it remains equal. And so we have looked over almost all of this. We're going to continue to use these in proofs. So let's go to our calendar real quick and take a look at where we've been and see that you guys took the test on Friday, and it's now Tuesday, and I'm not quite done grading. But I think, has everybody taken the test at this point? Is there anybody in here that has not taken the test? You have not taken the test? Will I see you in the morning? Awesome. Okay, so we're not going to talk about the test as of yet. But hopefully those tests will be graded tomorrow. All right, I'll go ahead and make the statement, and then I always follow through. The test will be graded tomorrow. Okay. So, let's look at this. Oh, we're going to do some proofs. And then tomorrow, what are we going to do? Prove. And then the next day, what are we going to do? Prove. And then the next day, what are we going to do? Prove. And then the next day, what are we going to do? Prove. And the next day, what are we going to do? Prove. And the next day, what are we going to do? Prove. And then we're going to start our review. Approving. And then we'll take a benchmark on the 7th, because those are fun. And then we'll finish up our review, and then we'll take our test on March 11th. And then we get to, I like this next unit. Right triangle trig. Oh, you're going to like it too. Trigonometry. Right triangle trig. Okay. So this whole section, we're going to intertwine into this. Lots of different proofs. So today, we're going to start with some proofs on parallel lines, and we're going to do that today and tomorrow. Then we're going to prove some things about triangles the next 2 days. And then the next 3 days, we're going to do parallelograms and special parallelograms. And this is kind of revisiting, because we've already talked about parallelograms and rhombus and rectangle and square. We've already talked about it, but now we're going to come back to it with proofs. Now, yesterday we had our construction day. Today we're going to practice some constructions. Tomorrow we're going to practice some constructions. We're going to keep the constructions going throughout too. We're going to do some constructions here with our centers. And then we might visit some of that on our test, but what is due on the 12th? The construction project. Okay? Yeah, that's due on the 12th. It'll be good. It's all good. Okay, so today we're going to start by opening our workbooks to page 47. Now guys, if you didn't have your workbook here at school today, please make sure you bring it the rest of the week. We'll be using it. And if you don't have it, just write down the page numbers on some notebook paper and you can follow along later.
We did this.
Yeah, you've done this. Okay? So the first thing it reminds us of are our angle pairs that are formed when we have 2 lines that are cut, both cut by a third line. So these 2 lines that are cut by this third line, and we call that line a transversal. So it's a line that intersects 2 coplanar lines at 2 different points. Now, we have several types of angle pairs that are formed when this happens. We have corresponding angles. Now, corresponding angles just have to be on the same side of the transversal and in the same position. So we would say that 1 corresponds to 5 because both of those are to the left of the transversal and they're above P and Q. Okay? What corresponds to angle 2? 6. What corresponds to angle 3? 7. And 4? 8. Those are corresponding. Same side interior are the ones that are in between the two lines and on the same side of the transversal. So 3 and 6 and 4 and 5. Alternate interior are on opposite sides of that transversal, but on the inside of the two lines, so 3 and 5 and 4 and 6. Alternate exterior are on opposite sides on the outside of the two lines, so 2 and 8 and 1 and 7. Now, in particular, if line P is parallel to Q, then corresponding angles would be congruent, wouldn't they? Same side interior angles would be supplementary. What does supplementary mean again?
Equal 180.
Okay, the sum is 1/8. Good. Alternate interior angles would be congruent. Alternate exterior angles would be congruent. Okay? We have one supplementary and the rest of them are congruent. Now, if the two lines are actually parallel and look like it, most of the time you can just look at them. If it looks congruent, it's congruent. If they look different, they're supplementary. Now, these are not parallel, so we could just look at them in this case. Now, the last thing I want to remind you of, and this was actually in a different section, but there's not enough in that different section to actually focus on it, and it's a linear pair. And a linear pair are when we have angles that share a common side and form a line. So see how angle 1 and angle 2 form this straight line, and they share this common side. Now, linear pairs are always supplementary. So 1 and 2 are a linear pair. 2 and 3 are a linear pair. 3 and 4 are a linear pair. We can tell that just by looking at the graph, can't we? Okay, any questions about the definitions? All right, flip over to page 47. Oh, you're not flipping. That's just at the bottom of the page, isn't it? Sorry. All right, so this is where it goes and says, if parallel lines are cut by a transversal, then same side interior angles are supplementary. Okay? So, explain how to find the measure of angle 3 if P is parallel to Q and the measure of angle 6 is 61 degrees. So, let's talk about the relationship between 3 and 6. What kind of special angle pair are 3 and 6? They're same side, which makes them supplementary. So if this is 61, then the measure of angle 3 would be 180 minus 61, which is 119 degrees. So if I gave you two parallel lines and gave you one of the angle measures, you could find all 8, couldn't you? Because if this is 61, then the alternate interior would be 61, the corresponding would be 61, the alternate exterior would be 61, which is also a vertical angle to 6, isn't it? And then we just found that this is 119, so this vertical angle would be 119, this alternate interior would be 119, and this vertical would be 119, and we could look at them all. We could define that a lot of different ways using those angle pairs we just discussed. Okay, flip on over. This would be on page 48. Now, this is having us prove that alternate interior angles are congruent. So since we're proving that alternate interior angles are congruent, could we use that as a reason? No, because that's what we're trying to prove.
That'll be like the last statement, right?
So, actually it's not even the last statement. We can't use it, we're just proving that they are. And so to prove that they are, we have to use other things. Now, here you have like a word bank. Let's see what you can do. Talk to your partner, talk to those around you, see what you think. How would you fill in the reasons for 1 through 8. Are you skipping number 4? Yeah. Skip number 4, everybody. We'll talk about number 4 in just a minute. Skip reason 4 and see if you can get the rest of them.
Can each thing be used more than once?
You can, because we only have 6 and we have 8 blanks.
Oh, yeah. I'm looking at it.
No.
That's how it's done. Okay, how many decided that number 1 was given?
I did.
Okay, what do you think about number 2?
Same side of here.
I like it. Same side, interior, angle postulate. Okay, what about number 3?
Definition of subangles.
Very good. Definition of supplementary angles.
And I skipped number 4.
Yeah, we all skipped it. Skip that. We'll come back to it. All right, number 5.
Linear pair theorem.
Linear pair theorem.
Shout out all pairs.
Number 6.
Definition of supplementary angles.
It is. Definition of supplementary angles again. Number 7.
Substitution property.
Substitution. And then subtraction. And let's talk about why. Okay, so I think we're probably good through 3, and 5 makes sense. Now, if they're supplementary, then they must add up to 180. That's the definition of supplementary angles. Now, do you see here I have 3 and 6 equals 180, and 5 and 6 equals 180. So both of these equal 180. So can I substitute in this 3 and 6 for the 180?
Yes.
Yeah. And that's why it's substitution. Now, do you guys see if we subtracted the measure of angle 6 from both sides? We'd be left with this.
Oh, that's right.
So that's why that's the subtraction property of equality. All right, now this one. According to our text, they want to say this is given. But do y'all see it?
No.
No. They want to see it's given because of the picture. But in old school geometry, which you have an old school teacher, you can't say that. You have to have a reason. And so if this were mine, I would say these are a linear pair because that is the definition of linear pair. Because if I look at the picture, I can see, ooh, 5 and 6 are two angles that share a side and they form a straight line. Now, because they are a linear pair, they equal 180. They're supplementary, so they equal 180. So this is what the book had. It said use given again. I'm not real keen on that. I think it would be much better to use definition of linear pair, which was not a choice. That's why I used given. Make sense? All right. Let's look at another. Ooh. We're proving corresponding angles. You see that? We're proving. So can I use corresponding angles are congruent as a reason? No. All right, let's see what you can do with this one. Talk to your partner.
I like having the word there. That's pretty nice.
Now, this one's only 4 steps, though. Yes. Yes. You just can't use what you're proving.
It's up top, and so like there's this over there, and there's like, and you have like the Tuesday thing.
I don't even notice it.
Like all, and like all the other grids, they had like number lines,
What?
but I really don't think they're reading number lines anymore.
There's pretty pictures back there for me.
What?
This direction.
Never realized how boring it was.
I would probably guess they would help.
It'd be distracting, so this is good.
Yeah,
Alright,
yeah.
okay, good.
Because students, this is not successful. Man, I needed that number line.
Yeah.
That basic.
Okay. Alright. Were y'all able to get 1, 2, 3 by yourself? All right. So now let's take a look at these. 1 and 5. If this is equal to this and this is equal to this, you may have said substitution here. There's also another one I would approve. If you switch these two, if you switched 2 and 3, so if I gave you this proof and didn't give you any steps, and you wrote 3 before 2, then what I would say right here is transitive. Okay? Because the transitive property says if A equals B and B equals C, then A equals C. Okay? So we revisited transitive just a minute ago. To do transitive, though, if you were writing the proof, you really want it to flow in the right order. So you would have put 3 in front of 2, and then it would be very nice for transitive. I would accept both of these as an answer here. I think either will work in this situation.
I'll put definition of same side interior
But 1 and
for number.
1 and
But one is exterior.
1 and 5 are not same side interior. This one's outside. These are corresponding. 1 and 5 are corresponding. Okay?
Could you put 4, 2, and 3? Like I put the definition of alternate interior. So does it? You have to say that they are congruent. You can't put the definition.
You could say the well, it's really not even just alternate interior angles are congruent. Alternate interior angles are only congruent if the lines were parallel. If we have 2 parallel lines, then alternate interior angles are congruent. And that kind of leads us into what we're talking about next, which is the converse of all these. Now, if this were a year-long geometry course, we would have started off defining some things, and we would have called this a conditional statement. Okay, if P, then Q. If you clean your room, then you get to go out with your friends. If then. If you make good grades, then you get to keep your phone. Okay? Yeah. Okay. If you're disrespectful to your parents, then you're on restriction for a month. Okay? So, if then. But they can also be mathematical statements. If a polygon has 4 right angles, then it's a whatever. Okay? Now, well, let's say that correctly. If a figure is a square, then it has 4 right angles. That would work, right? Now, converse. A converse is where we switch them. A converse is where we switch them. Now, if a figure is a square, then it has 4 right angles. Is that always true? Yes. But if we switched it, if a figure has 4 right angles, then it is a square. Is that always true? So, a converse of a statement may not be true, because a converse just switches the two. Got it?
What's the point of it, though?
This is all part of logic. We have conditional statements, we have the converse, the inverse, and the contrapositive. And they all lead to logic. And we're not doing a full geometry class, so we don't get to study all the different parts. This was the class that my husband hated in college.
The logic.
Yeah, I loved it. Because I'm mathematical and it all makes sense to me. If P, then Q. If not P, then not Q. If not Q, then not P. Anyway, he hated it. So, with these though, the converse is true. If 2 lines are cut by a transversal so that same side interior angles are supplementary, then the lines are parallel, which is the converse of if 2 parallel lines are cut by a transversal, then same side interior angles are supplementary. In this case, the conditional and its converse are both true. So if we can prove same side interior are supplementary, then we have shown the lines are parallel. If we can prove alternate interior angles have the same measure, then we have proved that the lines are parallel. If we can show that corresponding angles have the same measure, then we have proved that the lines are parallel. Because these converse of these other theorems, in this case, is also true. Now, not always the case. Not every converse is always true, but it is here. Okay, so if we flip over to page 53, this is like really old school. You guys did this in 7th or 8th grade. 1 and this angle here, 1, and this angle here, 133. Is that what it is? How would you classify those angles? Same side interior, and they are supplementary. So if this is 133, what would this one be? 47. So we would classify those as same side and same side or supplementary. All right. How would you classify 2? And this angle marked here is 119 degrees. Corresponding. And are corresponding supplementary or congruent? Congruent. So if this is 119, then this is also 119. All right, now 83 and x really don't have a special relationship. But if this is 83, then its corresponding angle would also have to be 83. Now do you see that x and this angle form a linear pair?
Yes.
and a linear pair supplementary. So we would subtract 83 from 180, and we get 97 degrees. Okay, special angle relationship here between this angle that's marked with 8x minus 34 and this angle that's marked 5x plus 2. What is the special relationship? Alternate interior. Good. And our alternate interior congruent or supplementary? Congruent. So we can set 8x minus 34 equal to 5x plus 2. So 3x equals 36. So my answer is 12. Is the answer 12? No. X is 12. The question asks you to find the measure of D, E, F. So we're looking here. So we do 5 times 12 plus 2 is 62 degrees. Okay, so all this is old school. You did this last year. Do you remember doing this? Awesome. Let's keep going then. Okay, so all these questions take those same ideas and all they do is put them inside a word problem or make a more interesting picture. Instead of just giving you 2 parallel lines cut by transversal, it looks like a fence or a gate. Instead of giving you 2 parallel lines cut by transversal, it looks like intersections of roads. The exact same idea. Seats in the theater. But it's all the same. Do you think you could read through and apply the same ideas to word problems? Great! Then let's not do it. Okay. Now, flip over to page 55. We've just talked about the converse would be true. If corresponding angles are congruent, then 2 lines are parallel, right? What I'm going to walk you through, and they've already shown you every single step right here. What I'm going to walk you through is how to create a parallel line by showing that corresponding angles are congruent. So the way we do this, and I'm going to show you the steps, and then on the next page you're going to do one yourself. So what they have done is first they took this P and just picked some points on here. They picked a Q, they picked an R. And then they're going to draw in a transversal. So their transversal is going to go through P and Q. Mine always went through P and Q. Okay. So now what we're going to do is take this angle here and copy it right up here. Do y'all remember copying an angle from yesterday?
Yes.
Okay, so to copy an angle, we take the pointy end and we put it right here. We measure a little bit less, and then we'll do an arc. Make sure I'm right on cue. There we go. And we'll do an arc. And then I'm going to shift up here and do that exact same arc. Got it? Now, I want this arc to go through this line, which is why I drew the line longer to start with, because I knew I was going to want that to happen. Now what we do is we take and measure from this intersection, well, let's put it right here. Let's put it on that line. From this intersection to here. Got it? Then we're going to slide it up to that intersection. There. And we're going to swipe so that we have this. And what we tried to create is a parallel line. Does it look pretty parallel? Okay, do you see that's what they did here? Sometimes it's easier to see it happen in real time than to just see it done. So let's flip over to page 57 and let's see if you can do it. Okay, if you did not pick up the compasses, they're right over on the table. Compass and a straight edge. And go ahead and pick those up every day, so that way we can get a little practice with them every day. Okay, so the first thing you're going to do is draw in some transversal. It doesn't have to be a straight line. You can do it. It could look like that. Sure. Now make sure it's good long though, because the length kind of helps you. Of course, you can't make it that long. Okay, has everybody drawn in a line with their straight edge?
Yes.
Nice long one. Okay, now take the compass and put the pointy end at that intersection. Take the compass, pointy in at the intersection, make it smaller than P. Make it go less, a smaller distance than from the intersection P. And then make a big arc. Make sure it goes through the new transversal line you just drew and the old line that was already there. Now, do not adjust your compass. You're just going to slide the pointy end over to P and make another big arc. So I did an arc with a pointy end here, and then I did the same arc with a pointy end here. Two arcs. One arc there, one arc there. Okay, does everybody have the two arcs? Okay, now what you do is pointy end still on the line, measure over to, measure to here. Measure. Measure. And if you need to, do a little swipe to make sure you got it on the money. Ooh, that looks good. Okay, did everybody measure?
Good.
You're measuring from this intersection to that intersection. Measuring. And then you slide the pointy end to this intersection. And then we swipe.
Oh, and you draw your straight.
And then you draw your straight line. Now, not even close.
Parallel lines.
I'm sorry to adjust slightly from
Okay, mine don't look quite parallel, but they're close. Okay, now, why should these be parallel? Because I copied an angle. I created corresponding angles that are congruent. That's why the lines should be parallel. Because I copied the angle, creating congruent, corresponding angles. Okay, you try number 2 on your own. Okay, you don't do it from this point, you do it from that. Okay?
No, P goes like this.
I really don't.
I'm gonna do this. P goes like that. You gotta do yeah, this is that's not right.
Olivia, let me see her. It's okay. Sometimes with a pencil point, it's right to the point, it's actually a little harder. I kind of shove it just to help you keep it the same and do that. And then that tends to make it easier.
Maybe you go like this.
Yeah, because that's good. Creating a parallel line is one of the 10 things you have to do on your project, isn't it? Now you've had some more practice with that one.
I'm trying to make it orange for mine, and it's working, but it's not working. Because I want to be able to show off. I can just
I don't.
Okay, for those of you that don't have a compass at home, remember, my set of compasses and straight edges are in my room. My room is open every day except Thursday morning because we have math tea. Any freshmen still want to join math tea? Colton only told people for math tea, right?
no way. Wait,
People that want to
oh my god, I think you score without really having to try.
And you still doing
Yeah.
We've got 4 years.
No, I mean like
We only have 2 freshmen.
Bless you. I don't know.
I've never had so
Yeah.
I don't have any freshmen in there in accelerating and geometry. But it's individual. I never made a decision.
I did it.
If you always are thinking outside the box, that's a good thing. It's different in the box. So you like, do you just like the like what do you okay, we do multiple things and it depends on the competition. Almost every competition has a written test, and that's how they do individual rankings. And then
You know, understand.
most of the competitions have cycles. That's where they give you a question, and either as a team, or some of them are individual. You work on this problem, like you get it right in the first minute, you get like 5 or 10 points. You get it right in the second minute, you get less points. Some, if it's harder questions, they give you 3 minutes. We have one of the competitions we get a header relay. Where the first person hands it back, the next person takes their answer, plugs it in, the problem they were given, and then yes, if there's a weak link, you're in trouble. And then we also have power questions, which is more involved. My mom and
Oh, yeah.
But most of it is thinking outside the box. Actually, just makes you faster. And you're
Check the line parallel to AB.
Yes. I'm never prepared for this.
You will.
Yeah, so one semester.
We've already, but in the fall, Wednesday morning, everybody SBA, get ready. So we moved to Thursday, because once a month you have baby shower. But most of our team go back.
All right. Let's see. Could we answer these 2 questions? Which of the following facts do you use when constructing parallel lines?
No.
Yeah.
Woo! Alright, your homework's out in the textbook. And do make sure you continue to bring your workbook to class this week. When we have big pictures, it's easier.
Is that on the calendar online?
Wait.